This is one of those interview questions that separates beginners from professionals. When you're dealing with millions of rows in Pandas, memory errors, slow processing, and system crashes start showing up fast. So the interviewer wants to know, can you make Pandas handle large-scale data efficiently? Let's break down the key strategies that actually work. 1. Optimize data types. The first step, optimize your data types. Most people don't realize that Pandas defaults to using very large data types like 64-bit integers or floats. You can downcast them to smaller ones, like 32-bit versions, or convert repeated text columns into categorical types. This single step can cut your memory use by more than half. For example, changing a column of repeated customer segments like gold, silver, bronze into categorical data drastically reduces the memory footprint. 2. Vectorization. The next strategy is vectorization. Instead of writing slow Python loops that go row by row, you should perform operations directly on the entire Pandas series or DataFN. Under the hood, these are optimized C and NumPy operations. And that means 50 to 100 times faster execution for things like mathematical or conditional transformations. 3. Chunking. Then comes chunking. When your dataset is too big to fit in memory, you can read it in smaller batches, say 10,000 rows at a time, process each chunk, and then combine the results. This avoids loading the entire dataset at once, which saves both memory and processing time. It's one of the best techniques for dealing with files that are several gigabytes large. 4. Column selection. And finally, column selection. If you only need a few columns for analysis, don't load the entire table. You can specify which columns to load while reading the CSV or database. This seems small, but when working with massive customer or transaction datasets, it can save gigabytes of memory instantly. Alright, let's walk through how this looks in code, but instead of reading syntax, I'll explain the logic in plain English. We start by defining which data types to use. For example, we tell Pandas to store IDs as small integers, categories as categorical variables, and numeric amounts as lightweight floating point numbers. Then, instead of loading the entire file, we use chunking, meaning we read the data in small batches, like 10,000 rows at a time. For each chunk, we process or aggregate the data, maybe grouping by customer and summing the transaction amounts, and then append it to a list of processed chunks. Once all chunks are processed, we combine them into a final data frame. This method handles huge datasets easily without running out of memory. By applying these techniques, you can reduce memory usage by around 75% and speed up data processing by 10 times or more. The case study on this slide shows exactly that. A 10 GB customer dataset was optimized down to 2 GB just by changing data types and using chunked reading. That's the kind of practical impact interviewers love to hear. Now, why does this matter in real life? Because scalable data handling is what allows you to work efficiently in production. Whether you're processing event logs, financial transactions, or sensor data, optimizing Pandas ensures your pipelines stay fast, memory safe, and ready for deployment. It's not just about writing code that works, it's about writing code that scales. So if this question comes up in an interview, here's how I'd answer it. To optimize Pandas for large datasets, I start by converting columns to efficient data types like 32-bit or categorical to reduce memory use. Then I process data in chunks instead of loading everything at once, and use vectorized operations instead of loops for speed. Finally, I only load the columns I actually need. These 4 steps together can easily cut memory usage by 70% or more. That's concise, practical, and shows you think like a production data scientist.